class 12. Today we are going to discuss example 2.4. The question says that there are 4 charges placed on point A, B, C, D as shown in the figure on the corners of a square side having side length D. Then we have to find the work done required to put together this arrangement, and secondly we have to find the charge Q0 brought to the center E of the square, and 4 charge being held fixed at the corner. How much extra work is needed to do this? So the question is quite clear. There are 4 charges. We have to find the work done required to put these together. This arrangement means when we are having all these charges at infinite distances, we have to bring the charge to the respective corners. So how much work we need to do? Now we calculate the work needed for one way of putting the charge A, B, C, D. Suppose we have a first charge plus Q brought to A, then the second charge minus Q, and then third charge plus Q, and then finally fourth charge minus Q are brought to B, C, D respectively. The total work needed can be calculated in the steps. Work done needed to bring a charge plus Q from A to A from infinity when no charge is present is 0. So in this case there is no opposing force, no attracting force. But when we bring the second charge minus Q from infinity to B, while plus Q is already present at A, so therefore at point B some electric potential will be generated, will be developed due to presence of plus Q charge at A, and therefore the work done, amount of work done will be minus Q into electric potential at A due to the charge at electric potential at B due to the charge at point A, and that becomes minus Q into Q by 4 pi epsilon naught D, and that becomes minus Q square 4 pi epsilon naught D. Now in the when we bring the third charge plus Q from infinity to point C, then at point C, since there are charges at point A and at point B as you see, therefore these charges at point A and at point B will produce some electric potential at point C. So since you see the point B is at D distance from C, so we can have the electric potential at C due to the charge at B will be minus Q divided by 4 pi epsilon naught D. But the distance of point A from C is 2D square whole under root, that means root 2D, and therefore we have potential at C due to charge at A equal to, you see in the big bracket the potential is given plus Q divided by 4 pi epsilon naught D under root 2, and so the total potential at C due to charge present at point A and B will be given by plus Q within bracket plus Q divided by 4 pi epsilon naught D under root 2 plus minus Q 4 pi epsilon naught D. That comes out to be minus Q square 4 pi epsilon naught D within bracket 1 minus 1 by root 2. So far we have done some work in the bringing the second charge to its place and the third charge to its place, but when you bring the fourth charge, as we are doing this, then in the potential at point D will be due to the charge present at point A, will be due to the charge present at point B, and will be due to the charge present at point C. So So that way the potentials generated due to these charges are given within the bracket. Distance of A from D is a small d, distance of C from D is a small d. So we have charge by 4 pi epsilon naught distance times. And in the third case, distance of B from D is d root 2, and therefore we have the total potential within the bracket multiplied by the fourth charge minus q brought to this, and we get the work done in bringing the fourth charge is equal to minus q square whole divided by 4 pi epsilon naught d within bracket 2 minus root 2. Therefore the total amount of work done will be the sum of these three work done, expression for work done in last three cases, and that comes out to be minus q square by 4 pi epsilon naught d within bracket multiplied by within bracket 4 minus root 2. So this work depends only on the arrangement of the charges and they are how they are assembled. So you can very much understand that the amount of work done will vary according to the arrangement of the charges in their places. Now the second part of the question is extra work necessary to bring a charge Q0 to point E when the four charges are at ABCD. Then what we have to do is we have to find the electric potential at point E and then multiply it by the extra charge Q0 brought to the center. That will give us the amount of work done. But you can see since the charge are symmetrically distributed about the point E, means there are plus q charges on two diagonally opposite points and minus q charges to two diagonally opposite charges. Therefore the net electric potential becomes 0 at E, and therefore the amount of work done in bringing Q0 charge to point E will be 0. Thank you and have a nice day.